service, and this is our 360 lab view project. This is our upper part, and here we used two sensor as this is one is the LM35 and one is MQ2. LM35 one is the temperature sensor, which will detect our flame temperature or the room temperature, if this is on fire or not, and this gas sensor will detect the whether it has smoke or not. So, and we used the this GPS module. GPS module will take the coordinate of the location where this device is stored, and so they can take the measure and send the fire brigade immediately. And these GSM modules sends the SMS to the owner and the localities by automatically when this is in the case of fire. And we made the whole project in the base of an Arduino, and this is Arduino Uno R3, and we made a program for the Arduino so that this can detect the and make the procedure accordingly. So here, when in here where the gas and smoke sensor sends the data via through the A0 and A1 pin. A0 receives the temperature data, and A1 receives the smoke data, and by the process of it, and by processing that, by the code we have right, it will send display there is fire or there is not fire, and buzz the buzzer and or the speaker accordingly. And it also sends the data of the location and where this is fire or not, via the Arduino predetermined Arduino project. And we used our two motors here. This is one is the for the gas valve, and one is the for the oxygen valve, where if there is a lot of smoke here, it will operate a one motor which will open the smoke door, so the smoke can get rid of easily. If there is a fire, this will shut all the doors so that no oxygen can enter, and so fire cannot get higher. So here in our so if we just run the project, so here we can see that when the project is running, it, as, the now currently temperature is 60 and the smoke level is also high, as 79%, it sends the SMS, and it said that it is on fire. In virtual terminal via the comport, it will send the data to our this is our lab view protest circuits, and this is our protest circuits for the project of the 360 lab panel. Thank you.
Hello, I'm Ripa Shekhar. My ID is 1820108. My group name is Short Circuit. I did the Arduino code portion. This is our final Arduino code of our lab project. So first of all, a new instance of the servo object, and then we initialize some variables here. Then we include the liquid crystal library. The liquid crystal library allows us to control the LCD displays. The LCD display is connected with these pins, and then we include the tiny GPS library. We use tiny GPS because this library provides compact and easy to use method for extracting position, date, time, and also detect the location. Then we include the software serial library because this library has been developed to allow serial communication on other digital pins of the Arduino. For the serial communication, we select the 9 and 10 number pins, and then we initialize tx value for which variable type is byte. Then we create GPS, a new instance variable for the tiny GPS object. Then here we use 6 nong pin for the speaker, 7 nong pin for the red LED light, and 10 nong pin for the yellow LED light. And relay on 7, we use relay here because it is used to programmatically control on or off our devices. Then here we set the initialized value of the temp C1, and we initialize the value of smoke C1. Here we use input sensor pin A0 with sensor pin 1 and A1 with sensor pin 2, and we take one string variable here. In the setup function, we take 3 output, which is motor, txt, and relay, and here we attach the instance of the servo object with 13 number pin. Then we take another output, which is speaker, and then we initialize the LCD with 100 delay. Then we take two input, which are sensor pin 1 and sensor pin 2, and we take also three output here, which are speaker, red LED light and yellow LED light. Then we set the both both motor off for the starting up, and then we start the serial communication with our computer. In the loop function, we take two variable, TMC1 and SMOC1, and we also use analog read function because it returns the value from the specific analog pin present on the particular Arduino board. Here we use sensor pin 1 for TMC1 and convert the analog data to temperature, and sensor pin 2 for SMOC1 and converted the analog data to smoke. For the condition TMC1 is greater than or equal 50, or SMOC1 is greater than equal 30. For map the analog reading percentage, we actually use the mapping function and set delay 50. Here motor, red LED light, yellow LED light will be high, so everything will turn on. Here we use LCD function. This is all about the display that is show the fire status and send the SMS with the sound of the speaker. And here we also set our delay is 50. Here we use some another variables, and we use fget function and set delay 100 again. This is all about serial printing, which is for pass it to the lab view. Here we again use the LCD function for this display the fire status and sending SMS. Otherwise, we set relay low with 50 delay, and here our red LED light, yellow LED light and motor will be low, so everything will turn off. And here we again use the LCD function for display the fire status, and this is all about the serial printing, which is for pass it to the lab view. So that is all about my presentation. Thank you.
Assalamu alaikum. I am Sheikh Abdul Fahad. Now I am going to talk about the lab view part. As you can see, this is just the front panel where you can see a thermometer, a smoke level indicator, two black boxes, and LED for temperature, smoke, and fire alert. We are gonna come one by one. So there is a section named Visa Resource name where we are using comport 3 as we are using comport 2 in Proteus section. There is a small thermometer and smoke level indicator, and the black boxes are going to show temperature and smoke reading in a graph form, and the table control beside the black boxes is gonna keep track of time, temperature, smoke, and our IDs. So as you see from block diagram, the smoke and temperature part both are present there. So we just need to create serial comport. This specific block is used for clearing the buffer, and block next to it is used for opening it, and eventually we are using two read commands which are connected to the block above it, and these two blocks are connected to an array which is linked with table control that I have just showed in the front panel. Basically, this array contains all the information about smoke reading, temperature reading, and our IDs, and these IDs are just constant that I created inside the array. And I also use greater or equal function to temperature and smoke, so that if the temperature gets higher than 50 and smoke higher than 30, then the temperature and smoke and fire alert will be red. And I also use an OR gate, so that if temperature and smoke, any one of them gets high, then the fire alert will turn red. We also added a error handler, so if any error pops up, the error handler will handle it, and the whole thing is connected in a while loop. Thank you.
Assalamu alaikum, I'm Mohammad Ishraq Khan, and I'm going to showcase our whole project and compile everything together. So first of all, let's come to our Proteus file. In this Proteus file, we're going to put our Arduino code in the Arduino. So this is our Arduino code, and from this code we are going to copy this location of our file and paste it in our Arduino in this place. So after placing this location in this file, now our Arduino is ready to run. So if we now we are going to connect our lab view with our Proteus file with our COM port device. So COM port device, to connect it, we have to put our comp2 and comp3, comp2 in Proteus file and comp3 in our lab view file. To do that, we have to select our comp pin, and we put our put comp2 in here, and in our LabVIEW file we have put our comp3 here. Now we are going to run it. So if we run it, now our temperature is at 62 degrees and our smoke level is 58%. We can see here that our file is being sent, and the temperature is rising here, and our smoke level is getting detected. So this is our LabVIEW file, and we can see that the temperature is uh, reading correctly, and our smoke level is also reading correctly. After every simulation, we can see that that we are getting 58 here, and 58% in our smoke level, and 58 almost 60 in our temperature, just as uh, in our Proteus file. So this is how our project is working, and every data is being sent here. Thank you.